Okay. So, you remember how to find the factors of a number like 24? Or what are the factors of 24?
2,
Okay.
4.
2, 4, 6.
All right, let's start with 1. 1 times what would be 24?
1, 24.
Okay, and then 2 times,
12.
okay, 3 times,
8.
4 times,
6.
5 times,
Nothing.
okay, anything else?
No.
No.
Because you'll have to.
Okay, so it starts to go back down, doesn't it? So how many factors is that in all?
4.
4, actually, but
8.
8. Because 1's a factor, 2's a factor, 3's a factor, 4, and then 6, 8, 12, and 24, right? Okay. And then what does it mean by prime factorization? Remember with
Is that even numbers?
those are,
No.
no, they're prime numbers. Like, what's a prime number?
Numbers that only multiply by themselves
In
in
1. Okay, so the only thing that will go into them are themselves in 1. Like,
2.
give me an example.
2 is in 2.
2. What else?
7.
7. Okay, those are prime numbers. Okay, but this is not a prime number, but we can write it as a factors of prime numbers. So we want to break it down all the way till we get prime numbers. What could you multiply? Remember factor trees?
9
Oh,
and
yeah.
7.
9
Or
times
9 and
8. Okay. So 9 times 8. And then we'll multiply. What about 9?
8. 3 and 3.
And then 8.
2 and 4.
Okay. Are we done?
No.
We can do what? The 4. So I'm going to go ahead and bring down the 3 and the 3 and the 2. And then on the 4, I'm going to put 2 times 2. All right. So that's the prime factorization of 72. 3 times 3 times 2 times 2 times 2. Because they're all prime factors. And then how can you write that with exponents?
2
3 squared.
Okay. Yeah, you can do 3 squared times 2 to the third or 2 to the third times 3 squared. Either way. Okay. Right, but these are all factors. These were all factors of 24. Okay, now we can use the greatest common factor to simplify 36 divided by 48. So we're looking for the greatest number that will do what?
Go into both.
Go into both. So what is the greatest number that goes
12.
into both? 12. So divide the top by 12 and the bottom by 12. What's 36 divided by 12?
3.
3, and 48 divided by 12.
4.
Is that reduced all the way?
Yeah.
So 12 was the greatest common factor, wasn't it? Okay. Okay, so what does it mean to factor a number or to find its factors?
Simplify.
Well, kind of.
Find what numbers make that number.
Okay, and what numbers do what to make that number? Multiply. Good. So we're going to find the numbers that multiply to get that number. Or you could say find what multiplies to get that number. All right, so then we've got these polynomials. Well, these are two binomials that are multiplied together. And they used FOIL, and they got this, and then they combined the 2xy and the 12xy, and they got 8x squared plus 14xy plus 3y squared. So it's considered this problem above right here. What are the factors? Which ones are the factors?
Yes, 14 and 3.
I know, but it's a good try. That's what a lot of people think.
2, 3, and 4.
No,
2
Oh,
and 2.
2.
2 and 2.
no, actually, it's this whole thing. Like, this is a factor, and this is a factor. Like 2x plus 3y is a factor, and so is 4x plus y. Why are those factors?
Because you're multiplying
'Cause you-
together.
Yeah, you multiply these together, you get the polynomial.
Yeah.
Okay. Okay, so what does it mean to factor a polynomial? You find what multiplies to get the polynomial. So we're looking for, a lot of times, two binomials that will multiply together to get that polynomial. But what we're going to do first is look for the greatest common factor. And then we're going to factor it out. That's how we say that. So if we look at 6x squared plus 14x, we're looking for the greatest common factor of 6x squared and 14x. Something that'll go into both of them.
2.
2. 2 will go into 6 and 2 will go into 14. What about x? Will x go into both of them? Is there an x in both of them?
No.
There's not an x here and an x here?
Oh, yes.
There is. There's an x in this term, and then there's an x in this term. Is there an x squared in both of them?
No.
No. Okay, so we're going to factor out the greatest common factor of 2x. We're going to put 2x here. Then we're going to have parentheses. So 2x times what would give you 6x squared? 3.
Square.
3x squared, because you got to multiply by this.
Just 3.
Would it be 3x squared or just 3x?
Just 3.
Okay, because x times x is
3.
x squared. So 2x times 3x would be 6x squared, wouldn't it? Okay. Plus 2 times what would give you 14x?
7.
All right, so if you multiply this out, distribute the 2x, do you get 6x squared plus 14x?
Yes.
Yes. So what are the factors of that? One factor is 2x, and the other factor is what, Michael? 3x plus 7. Okay. Because these two things multiply together to get this. Okay. What we're kind of doing is undistributing, because if you distribute that 2x, you get that, and then if you take the 2x out or undistribute, then you get this fact. Okay. Okay, let's try the next one. What is the largest number that will go into 4, 6, and 10?
2.
Okay, and then we've got it. Do we have an a in everything?
Yes.
Okay, is there an a squared in everything?
No.
No, so we can't use a squared. We have to choose the least exponent. So these have 1s, and so we choose a to the 1 or just a. Okay. What about b? Is there a b in all of them? Do we need b or b squared? B. Okay, because that would be the least or the smallest exponent. It would be b to the 1. Okay. So we have 2ab, and that's our outside factor. That's what we would distribute to get this up here. So 2ab times what?
2a.
Okay, good. You need a 2 because 2 times 2 is 4. You need an a because a times a is a squared, and then we already have the b. Okay, plus.
3b.
Good. Plus
-5.
would be -5.
Yeah.
Okay, because 2ab times -5 would give you -10ab. And normally we don't put plus negative, we usually just put -5. Okay? Okay, y'all remember this kind? Okay, I know you've done it before. All right, we got. Oh no, we got a next page.